Hello there, I'm Jaime Blasco, and this is a series of videos where I'll be explaining some core concepts about Flutter. Most of what you will learn here won't be needed in your app, but it will help you to understand how Flutter works and how you can take advantage of it. Let's get started. So, starting from the basics. In Flutter, everything is a widget. Our app is composed of small different modules that we call widgets, and we nest one inside another, creating what we call the widget tree. Another popular phrase is, there is a widget for that. In fact, there is. Every widget tries to solve something very specific. It is key in our app to try to do the same. The more encapsulated we have our UI, the better it will be for performance, finding errors, maintenance, testing, and much more. But what is a widget? A widget is just a dark class that contains the information of our UI. It is special because it is immutable. Once we initialize the class, we cannot change the properties inside. And we nest these widgets one inside another, creating our app. Also, widgets are and should be light. There is not much computational cost of constructing and deconstructing these classes. They only contain minimal information. For example, the widget text is only stored in the string and some other styling parameters. Every time you update part of your widget tree, Flutter will be creating new instances of all the widgets inside. It sounds heavy, but it's not. And this is it. Flutter is just a tree of immutable classes that define our UI. But UI is not immutable. We expect it changes in different states. So, how does Flutter control the state? Well, widgets are not enough. There are two more trees in our apps. One called Elements tree and another one called RenderObjects tree. To make it simple, the widget tree defines the information of our UI. The element tree will handle the state and life cycle of the widgets and keep it in sync with the RenderObjects tree. And this last one is the one taking care of the layout, sizing, and painting of our content. Let's continue with the elements tree. An element represents the use of a widget in a very specific location of the tree. Over time, widgets can change, but elements don't. They have a life cycle. Then when they are created, mounted, updated, and unmounted. For every widget in the widget tree, there is an element that controls its state and life cycle. So every time we create a widget, his element is also created and mounted. If we want to update our UI, the widget tree is rebuilt. Well, at least the part we want to update. But the element tree is more clever. It detects what changes happen in the widget tree and it updates its elements accordingly. Same happens if a widget is removed. If a widget is removed, his element in that position will also be removed. Notice we could use the same class widget instance in the different positions of the tree. But the reference of that widget in that position, the elements won't be the same. This is very easy to understand with the stateful widget. A stateful widget is a widget that has a state. Wait, we said widgets are immutable, they cannot change. Yes, this is still true. The stateful widget is still immutable. What is not is the state class that goes with it. So when we add the stateful widget to our tree, the stateful element will store the state. So every time our widgets are rebuilt, the state will be the same. Let's recap. We have widgets that contain the information of our UI and can be updated whenever they want. Elements that control the life cycle of these widgets. But we still don't know how to paint or position the content in our display. Well, this is the job of the RenderObjects. The RenderObject lays out, gives a size, and paints out your content. As you can see, this is where all the heavy part happens. It is. These objects are really heavy. They have a lot of reference to other classes instance like his RenderObject parent, render layers, and also calling his methods usually involve a large number of calculations, both inside the Flutter framework and inside the render engine. So it is key to make minimal changes to these classes. Only when it's really needed, the more optimized it as possible, and in synchronization with the rest of the render objects. I will be explaining more in detail about this in the upcoming videos. Let's go back to the trees. For every widget in the tree, there is an element. But it's not the same with the render objects. Not all widgets need to paint something. Stateless widgets, stateful widgets, feature builders, providers, and a lot more of this allows you to compose more widgets together or manage some state, but they don't require to paint or layout anything. So only some widgets will have its corresponding render object. Let's now see how the render objects work. For that, we will be using the align widget. When we add this widget to the tree, his element will be also mounted to the tree. In this case, it is a single tile render object element, and this means the element will only have a render object as a child. When the element is created, it also creates the render object with the corresponding parameters. And once we have all the trees built, the render objects will be positioned and painted. What happens if the widget tree is rebuilt? The element will be in charge to update the render object. In this case, as the alignment parameter has not changed, the render object won't position and paint itself again. It doesn't need to. If we update the widget tree, this time with a new alignment, the element will update the render object with the corresponding value, and the render object will mark itself as needed to be relaid out. So, once the tree are rebuilt, all the render objects that are required to be positioned or painted will do at the same time. There is a lot more about how this process works than what I have explained here today. In the following videos, I will explain you some of these topics in detail. I hope you like this video. If you find it interesting, please like it and share it with others. Goodbye!